Today we'll be doing the sum from 0 to infinity of -1 to the k over 2k plus 1 cubed. And to start off, we will break apart the sum into its even and odd components. So we're going to have the sum from 0 to infinity -1 to the 2k over 2 times 2k plus 1 cubed plus the sum from 0 to infinity -1 to the 2k plus 1 divided by 2 times 2k plus 1 cubed. And so we're going to have the sum from 0 to infinity of 1 over 4k plus 1 cubed. And then we're going to have plus the sum from 0 to infinity. This will become a -1 over, and then we're going to have a 4k plus 2 plus 1, but that's a 4k plus 3 cubed. So we have the sum from 0 to infinity 1 over 4k plus 1 cubed, and then we have a minus the sum from 0 to infinity of 1 over 4k plus 3 cubed. And for this second sum, we're going to make a change of index from k to k minus 1. So we're going to have the sum from 0 to infinity of 1 over 4k plus 1 cubed. And then we have a minus the sum from 1 to infinity of 1 over, we're going to have 4 times k minus 1 plus 3 cubed. And so this inner thing, we have 4k minus 4 plus 3, but that's 4k minus 1. So we have the sum from 0 to infinity of 1 over 4k plus 1 cubed minus the sum from 1 to infinity of 1 over 4k minus 1 cubed. And from here, we're on the second sum, we're gonna go from k to minus k. So we have the sum from 0 to infinity 1 over 4k plus 1 cubed minus the sum from -1 to negative infinity of 1 over -4k minus 1 cubed. But we could factor out a negative, so we have a -1 cubed times 4k plus 1 cubed. But -1 cubed is just -1, but that -1 cancels that negative. So we're just left with the sum from 0 to infinity 1 over 4k plus 1 cubed, and then plus the sum from -1 to negative infinity of 1 over 4k plus 1 cubed. And so we put this into the form where we're summing over all integers. So we have the sum over all integers k of 1 over 4k plus 1 cubed. We could make this look a little nicer, and so we're going to have the sum over all integers k of 1 over 4 cubed times k plus 1/4 cubed. So that's 1 over 64, sum over all integers k of 1 over k plus 1/4 cubed. And so from here, we're going to use an identity, and that is pi cotangent of pi x is the sum over all integers k of 1 over x plus k. And this is valid when x is not an integer. So using this identity, we're going to differentiate with respect to x. So if we do that, we're going to have pi times negative cosecant squared of pi x. By the chain rule, we're going to have this extra pi. We have the sum over all integers k of minus 1 over x plus k squared. This negative and this negative will cancel. And so if we differentiate again, we're going to have pi squared times 2 cosecant of pi x. And we have a negative cosecant of pi x cotangent of pi x times the chain rule with another pi. And then we're going to have the sum over all integers k of minus 2 over x plus k cubed. And this negative will cancel with this negative, and this 2 will cancel this 2. So we're going to have the sum over all integers k of 1 over x plus k cubed is equal to pi cubed cosecant squared of pi x times the cotangent of pi x. And now from here, we'll multiply both sides by a factor of 1 over 64. So we have 1 over 64 and a 1 over 64. And now we're just going to let x equal 1/4. So letting x equal 1/4, we have 1 over 64, the sum over all integers k of 1 over k plus a fourth cubed is equal to pi cubed over 64 cosecant squared of pi over 4 times the cotangent of pi over 4. But this is exactly the sum we're looking for. Cotangent of pi over 4 is 1. So we have the sum is pi cubed over 64. Cosecant of pi over 4 is 2 over the square root of 2, but we have to square it. So we're going to have pi cubed times 4 over 64 times 2. So we have a 2 pi cubed over 64, but that results into pi cubed over 32. So you can say now, therefore, the sum from 0 to infinity of minus 1 to the k over 2k plus 1 cubed, this results into pi cubed over 32.